The title for the talk is actually the Balancing Resilience and Cybersecurity in OT Environment. Let me read his bio. Paul is a lead cybersecurity analyst at SecuriSect. With 28 years of expertise across multiple industries, Paul leverages a broad background in both IT and OT cybersecurity, risk and compliance, supporting the nation's critical infrastructure. Paul provides tailored guidance, charting a course through challenges in enterprise architecture, process and industrial control systems, IoT, and cloud security. Paul's strategic insights have consistently empowered organizations to make informed decisions to meet challenges, goals, and mission objectives. Paul serves on several industry advisory boards, including the local Minnesota chapters of InfraGard, the Information Systems Security Association, the International Society of Automation, helping to deliver relevant and timely cyber-informed content to organizations, agencies, membership, and local industry. Paul also collaborates closely with local high schools, colleges, and universities, not just as an instructor, but also as a mentor. Paul offers guidance and support on both student career path decisions and academic curriculum development. His commitment to education bridges the gap between academic learning and real-world challenges, but also inspired countless students to embark on meaningful and impact careers in technology and cybersecurity. Paul, it's a great honor to have you again for this CAR Symposium. The floor is yours.
Let's see, do we have... Is this on? Oh, there we go. Can everybody hear? Okay, good. And then, nice. See if we get this plugged in. The nice thing about Brian's presentation is we'll be getting into that second rule there a little bit. Here. So, and 2025 speaker slides. Oh, there it is. Let's give. All right. So the good news is we've already gone through this. So thank you very much, Prakash. I appreciate that. As he had mentioned, also doing a lot of mentoring and then working with students. And then to save on photos, so down there at the bottom, you can connect with me on LinkedIn. You'll probably get a copy of this anyway. But I always give folks the opportunity to connect with me. I'll send a PDF of the version, and in this version, you get like a, like, what would they call that? Like a sale, a bit like the early special. So connect with me on LinkedIn. Sometimes you have to send me a message, LinkedIn traffic, and then just send me a message. Let me know what you're looking for. And then also, never miss an opportunity if you've got questions even beyond today. Never miss an opportunity to shoot me a note. I always try to answer in a timely fashion. Sometimes if there's a couple of days of delay, just recognize that I will get back to you. And I do love helping students out. Part of my background, it was interesting when Brian was speaking, is I started out in high school in fine arts. And I was doing set design for the local high school, for the play, all the plays. I had started off in college as a fine arts major, and I had gotten through the first semester. And it was towards the end of the first semester, as I went to the bookstore, and I was kind of lining up what my books would look like for the second semester. And I saw art history. Has anybody ever had to take art history? Because the book on that bad boy is the history of art, and it's like 2 pages or 2 inches thick. And I went to my academic advisor, who also happened to be the dean of the communications school. I said, Mike, I am not going to be able to be a fine arts major here. He says, why is that? And I said, there's no way I'm going to read a 2-inch thick page book in a semester. So he said, well, good news is we've got a communications school. It's advertising, public relations, and graphic arts. You get some of the arts stuff there. He goes, and really what it requires a lot of critical thought and talking. If there's one thing, Paul, you do a lot of, it's talking. So That was for me, graduating in an odd twist of events, having a communications degree and ending up in IT. And actually, to Brian's point about the business aspects of things, it's become increasingly more valuable to communicate ideas in technical terms, but to non-technical folks. So I think that's always, when I'm chatting with students as they're going to enter the workforce, it is being able to come out of yourself, maybe not look at the shoes, but then looking out, and being comfortable with the content that you're talking about, the individuals, and then being comfortable with yourself. Find strength to self, because you're going to be the future defenders if you're in the IT security space for critical infrastructure, which is what we're going to get into. I want to start with a show of hands. How many high school students do we have? Nice. How many college and university students do we have? Okay. How many professionals? Okay. How many are either looking forward to getting into or currently practitioners in the cybersecurity space? Could be InfoSec, pen test, any type of defense. So is anybody in there? Okay. How many are in the engineering side? Engineering? Okay. So what I'm going to be talking about is balancing cybersecurity and critical infrastructure. And unfortunately, these two things are diametrically opposed. And it really dovetails into a lot of what Brian was talking about in terms of open architecture, why things are open in industrial communications protocols and critical infrastructure. So up here on the screen, we've got the 16 sectors of critical infrastructure. Does anybody know how many sectors are currently recognized in the state of North Dakota? Of the 16. It's actually a trick question. So what we'll find is in the Midwest, and I'm from Minnesota, in the Midwest, most of the states happen to have all 16 sectors of critical infrastructure. So what we're going to do is focus on a few of them within there and just kind of talk about what this is, because critical infrastructure is all around us. As we now know from Brian's presentation, it's also circling us. Because communications and aerospace, space and defense, which is here in critical manufacturing, is a significant portion of critical infrastructure. There's also overlap in terms of not only securing the critical infrastructure in manufacturing, where you have automation and industrial control systems, but we'll also start talking about where we have IT systems that are also in the OT space. And whether you're working directly under a DoD contract, DFARS, anybody heard of CMMC? It's kind of hard to miss these days. Yep. So you have I do a lot of work not only on doing OT and ICS assessments and helping organizations shorten up their gaps, but I do a lot of work in working with DoD contractors, typically the subs, and be able to do a gap analysis and get them prepared for their CMMC assessment for certification. So, and there's a lot of things that are going to translate when we're talking about how do we want to shore up. The NIST SB 171 actually has a lot of overlap with NIST 882, ISA 62443, and other frameworks that we would talk about securing critical infrastructure. Your defense industrial base and manufacturing, it's going to be with, there's dependencies on transportation systems, energy, so on and so forth. We look at another one, the energy sector itself. It's a few levels and areas, and then here in North Dakota, we've got this critical infrastructure. So this is going to be power to an outlet. It's going to be fuel systems. So, and all of this is dependent on automation systems or industrial control systems. Food and agriculture. So in food and agriculture, in the move from 4G to 5G, cellular device capabilities become a very cost-effective and efficient method for communication. By the year 2030, it's expected that there'll be 5 billion devices communicating over some sort of cellular RF communication that is involved in agriculture. Everything from autonomous systems, watering, irrigation, and anything that has to do with the conveyance or the movement of food from the field, and then into whether it's restaurants, your kitchen, refrigerators, supermarkets, doesn't matter. And then you can see some of the numbers here, but we have 700,000 restaurants, 220,000 registered facilities, all dependent on food and agriculture as a critical infrastructure. Transportation sector is important for a variety of reasons, and they're pretty, I mean, it's pretty obvious. We have to get something from point A to point B. So in transportation, it could be intermodal sites where we may not have them here, but where I've got freshwater or saltwater ports, and I've got the intersection of trains. A lot of that requires industrial automation or OT systems. It's also in flight. So airports, again, airport here, there's airports everywhere. So aside from the telematics and the ability to thwart the active communications on an airplane, there's also two more kind of ground truth things that can bring an airport to its knees. Anybody know what you have to do in order to keep an airport moving? What are the two things you have to move? Yeah. So people and their bags. You can't move bags, you can't move people. If you can't move people, can't put them on a plane. If you can't put them on a plane, plane can't take off. And if the plane can't take off, the plane that's coming in and going to get to the gate is going to land, but just has to sit there. So the baggage systems are largely based on OT automation. Also, in most airports, and it wasn't until working with the TSA and finding some of this out, is the airlines do not have points of presence within the airports. What they have is a data feed. So not all the baggage handling systems in the automation are the same, which means not all of the security that's put in place is the same, and not all of the software or the code is the same. It's very distributed, it's very disparate, and it's different from one airport to the next, which makes it a little bit challenging because every airport has to have their own security or cybersecurity program based on what they have, and then they have to continuously improve that. Water and wastewater systems. There's always this, I'll ask the question, there's always this debate that goes on. Of the critical infrastructure sectors, what's the most important? Energy or water? And I don't have a clear answer. But I do know that we depend on water for just about everything, right? We also depend on energy for that as well. The thing about water is 80% of the nation's critical infrastructure in terms of water is also run by private industry, which, similar to the airports and their cybersecurity programs, is very different. Water and wastewater is a very mature industry. And by mature, I mean that it's a race to zero. A lot of the bid, build, design engineering groups that are supporting water critical infrastructure, they will put out statements of work for either ongoing maintenance or new sanitization or clean water facilities, wastewater facilities. And what is the one thing that is typically missing from the line item list of the statement of work? Anybody? Cybersecurity. And if it's on there, it's typically from a dollars and cents perspective, the first thing that comes off. So 80% of the U.S. receives that potable water from these sources. 75% is the sanitary. You got 152,000 drinking water systems throughout the United States. And all of them are running some form of automation and control system. So critical infrastructure is comprised of automation systems performing activities. But what we'll do is we'll get into what makes up those automation systems. And I'm not going to go into all of these. We'll touch on a few of them and how they're related. But we'll start out with the programmable logical controller, or the PLC. The interesting thing about the PLC is when Brian was talking about the small little computer in there, it's got limited RAM, limited processor, and limited capabilities, and it's only designed to do what it does. And he likened it to like a Raspberry Pi. Well, a PLC is not all that different. It's small in nature. It's relatively compact. In fact, of these, see the one in the upper right or the upper left there, that's a Rockwell Allen Bradley control logics. That's probably one of the larger ones that you would see on a backplane inside a control panel. Who's ever seen the inside of a control panel? All right. Some of the other ones, they're much smaller. They're purpose-built. They operate in hazardous or extreme environments, like Prakash was talking, where winter hasn't quite come yet, but with the wind, man, you guys got some wind out here that is nuts. But when it gets cold, a PLC is designed to operate at very extreme temperatures, whether hot or cold. It can also operate where most computer PCs, like everyone here, pretty much has a laptop or some sort of a portable. It wouldn't take long in an industrial control systems or OT environment for debris and contaminants to get in there and start disrupting the normal operation of your PC. You'd have to blow it out. That's where if it was a small computer, you'd take the dust off, and it's not only there's a dust bunny, there's like a colony of them, and it's just filled in. But PLCs can operate in that kind of an environment because they're purpose-built. They handle the control and machinery assembly line, sequential monitoring, motion control. They're also networked, and they become part of and can be part of a distributed control system, which is a series of PLCs that are all working together to perform some sort of an end process. So a type of control system where the elements are dispersed. So let's talk about PLCs in a distributed control system. So across the top of the blue line, that's the Ethernet communications and connectivity. And then below that blue line, we have other components that are part of a process. And we'll talk shortly about the difference between protecting data and protecting a process. But in this diagram, which is a very basic diagram, I have across the top, I've got an engineering workstation, I've got a SCADA system, and I've got an HMI. Typically, these are going to be Linux or Windows-based. The vast majority of your engineering workstations are Windows-based. The other thing is the software that an engineer would use to connect to a PLC over the network, interact with it, change code, they're firmware version specific. So not only do I have one version of the software, if I have a PLC with older firmware, and a PLC can be put into operation for generally anywhere between 8 to 15 years. It'll do the same thing over and over and over again, sometimes 60 times a minute, especially in high-yield manufacturing. But it'll do this kind of operation, and it's rare that the firmware gets updated because there may be a release to it that's not important to the operation that the PLC is currently within or the process within the OT environment. But then there's a new development that goes inside the manufacturing space or the OT environment, new PLC, new firmware. What does that mean for the engineer? He has to load a different version of the software but retain the previous software he had. And what they started to do, engineers will have virtual workstations that go all the way back to Windows XP so that they can run the older code with the older software and talk to that older PLC. Even though the new PLC, you can run on Windows 10, Windows 11 software and versions. So we always have to be cognizant of that. The PLC is where we get into the cyber-physical. It's controlling something in the physical realm. It's doing data-driven, process-driven things, and it's controlling something in the physical realm. A particular type of PLC or operation is also called a safety instrumented system, or SIS. You're sitting inside one right now. Did anybody guess what the safety instrumented system for this room is? So we've got the fire alarm systems, right? So those would be the sensors. So smoke detectors would be the sensors connected over wire to a panel. Somewhere in this building, there's a red panel. And that red panel is going to take impulse and sensory data from the sensor. And when a particular trigger is met, it's going to have a reaction. It's going to either sound an alarm, it's going to send a notification, or it's going to do something within the physical realm to then save the individuals or the humans that are dependent on it. Your car also is a vast array, the ECM or the ICM or the computer system, the bus inside your car. as all of the sensors that it's taken information. And one of the things that we were talking about in that list of automation systems was the human-machine interface. Your electronic dashboard, or even an analog dashboard like me if your car is old enough and you got the tachometer and the dials, that's a human-machine interface, or an HMI. It is providing the human operator information about the physical processes, and it's doing it in a cyber way. It's transmitting and receiving digital information over the bus on the car, and it's relaying information to you based on what is the operation of the vehicle, certain levels, like a fuel sensor, or your, when we talk about water and wastewater, water levels and water pressure, fuel system, your tank going from F to E. Suppose for college students, usually sitting closer to the E more often than not, maybe. So, but that is it. The dials and the dashboard, those are a clear example of a human-machine interface, and everything else that you don't see is what is happening below with this remote I/O, PLCs, or what we call like the computer modules inside a car. So what are the adversarial threats? So what's interesting is we can get down into the weeds and we can talk about the industrial communications and protocols. But for adversaries, it's a lot easier to try to get to those engineering workstations, okay? And I think rule number 2 that Brian had up, there were 2 things there. Be pragmatic and prioritize the threats and the risks accordingly. And then don't waste time trying to think about the eloquent or exquisite, that was the word. The exquisite attack from a threat actor. There's also something, and we get into attribution a lot when we talk about adversaries. So China, or it's somebody else out there is attempting to, as a nation state, have sophisticated attacks against critical infrastructure. When actually, what we'll see is, anybody read the book, there was a book, it was Escalation Dynamics. Anybody read that book? That's a good one that focuses specifically on escalation dynamics between nation states in terms of hostilities, and how it's far more beneficial to a nation state to have a proxy actor operating indirectly on their behalf, or directly, because then the nation state in its response, like Russia saying that, well, we didn't attack you, it was this group over here. Yeah, well, they're on your soil. Yeah, well. So proxy actors are far more a problem than the nation state. Now, nation states, well-funded actors are going to be in your upper echelon in terms of sophistication, but the frequency is going to be very low. What you'll see is these types of attacks. So phishing, malware delivery, the ability to get somebody to click on a link, these are what you're up against. And this gets back to what I was talking about in terms of CMMC and protecting under contract with stiff penalties, by the way. Any system that is harboring, maintaining, sending, storing, forwarding, or interacting with controlled unclassified information. But substitute that with our data and our operations and our systems. It's far easier for a script kiddie to be able to send, especially now with AI, to be able to send a well-crafted email with correct punctuation. And then now you even have the creation of a thread that gives, for theater of the mind, will give the intended target or the victim the semblance of, this is not just a single unsolicited email, this is actually part of an entire chain. You should click on this link and then go to wherever I'm telling you, so that I can I can elicit this action. So man in the middle, modification of communication. Like Brian was talking about in terms of satellites, the same thing with industrial control systems. They're built for speed, productivity, efficiency, and safety. Has anybody ever heard of the CIA triad? That's probably a silly question, right? There you go. So confidentiality, integrity, and availability. Well, in the OT and the industrial control system and the automation, we have safety first, human safety. Safety can be for an individual, can be for a community, and it could be for a surrounding region. And then we have reliability. But it's not reliability uptime in terms of resilience, and I want battery backups, which you want. I want generators, which you do. But it's the reliability of the information, because the control systems have a target or a set point that they're trying to maintain. They have sensory data that's being collected, active in the process, that's being delivered to the PLC, and then the PLC is adjusting the automation to remain within the set point variance. So when I have a primary variance and I have a set point, I read that data and then I adjust accordingly. Probably 100, 200 years ago, we would have humans doing that. Now we have control systems that can be measured in microseconds and milliseconds that are taking information and making decisions on what's supposed to happen next based on the code and the programming and the operation of the process that they're actively engaged in. And then you can manipulate that data. Here's a question. Who's heard of Stuxnet? Right. So Stuxnet, 2010, perfect example of a manipulation of data to create a false presence of something that's taking place that's not. So centrifuges were reporting that everything was fine when actually within the reactor it wasn't. And we see the manipulation of data over and over and over again. But again, industrial protocols are open. It's an open architecture built for speed, productivity, and efficiency, and it lacks authentication, authorization, and encryption. And so what we have to do as cyber practitioners and defenders is start to build up the defense mechanisms against that, or your defense architecture, or your defensible infrastructure. Part of that gets into MITRE ICS. So we talked about MITRE ATT&CK in the first conversation. There's also a MITRE framework for ICS that will walk you through that. There's also the frameworks that I had mentioned earlier, and you could even apply NIST CSF to this, although NIST 882 is for industrial control systems. ISA, the International Society of Automation, ISA 62443 is specifically for automation, but 70% of what we find and where we want to get our defensible architecture to is also solved by NIST CSF 1 or 2. 2's got the privacy and the governance. ISO 27001 also gets into this. We take a look at Allianz, and they had come out with the threats and the risks that organizations are facing in 2025. Topping the list is cybersecurity. Natural disasters follow below that. Natural disasters are a risk and a threat, but cybersecurity is leading what the concerns are. And in supply chain disruption, has anybody heard of pipe dream as an attack? So when Brian was talking about reverse engineering gear for the satellites, so PLCs they're very similar in nature, although the manufacturing is different from one manufacturer to the next. So I can have Siemens, Rockwell Allen Bradley, Phoenix Contact, a host of others. Well, what's interesting is threat actors found that there were digital components that were synonymous with each of them. And so what they were able to do, very sophisticated, and within the pipeline, why they called it that, within the pipeline for supply chain, was to introduce code that would allow for certain activities to take place. And this went across manufacturing of all industrial control systems, regardless of the manufacturer, because they were all using that same component, that printed circuit board, that chip for that purpose. And it was the higher level PLC modules in and of themselves. So when we talk about the threat vectors and the numbers and what you're up against, so 98% of the time phishing is chosen as a threat vector, and it's pretty successful. So it's over 30% of the time it's going to be successful. When a beachhead is made, it's 295 days just to know that something's there. Some of the other numbers here, for those on the professional side, if you had to fill out any cybersecurity questionnaires for your insurance policies lately, those have gotten pretty expansive. I can remember helping organizations through that about 8 to 10 years ago, and those were probably about maybe like 30 or 40 questions. They were pretty basic. Hey, do you use PCs? Yep, got that one. Do you have passwords? Yep. But no one was going into what was the complexity in terms of your passwords. Well, now what we find is in 2024 and then going into 2025, 24% of the time, a data breach or first-party claims and exclusions may exist with a non-payout. So just under a quarter of the time, the insurance company is going to say, your policy is yours, you're going to do this, but you're not practicing that. 27% of the time, you have a partial payout. All right, we'll give you some of the money. But you can think about this in terms of an organization. These are the things that we can control. A lot of times I can't control like when something's going to happen, but at least I can try to get ahead of what might happen. Ransomware threats to critical infrastructure. You can see here there's been a significant increase over time. Why does anybody think that ransomware has significantly increased, specifically for manufacturing? It's easy. That's really all it is. Get somebody to click on something, and then I can start infecting the typically Windows. And that's where we get into certain levels of defensible architecture and isolation, segmentation, and then being able to try to segment and ward off those types of threats, where if I have a ransomware infestation, if I've got my OT system somewhere else, and I've got some sort of a barrier, whether it's logical, digital, or you're still air gapping, then there are opportunities to be able to protect those OT environments specifically for safety and then reliability and productivity. But we don't know what we don't know. So if I can't assess my risks and threats if I don't know what my assets are. So we see here, one of the biggest problems is, what do we have? Not sure. It would be like if you had a class here and you had a bunch of gear and then there was a red team against that. Now the red team acting in a black box can try to hack and figure out what they have. The blue team has to be able to defend that infrastructure and that architecture. What if I told both teams, you don't know what's there, but you have to defend it, and then the red team has to attack it? Red teams are used to operate in a black box, consistent convention. What if I told the blue team, you don't get to know anything about your assets, but I do want you to build a scalable and defensible infrastructure for it? You have to know what you have. So what's a resilient critical infrastructure look like? It starts with asset management. Figuring out what is it that we have, comprehensive inventory of assets, and then now it gets to some of what Brian was talking about. Now we're going to take a look at what are the risks associated with that. How are we going to determine what those are? And then recover quickly. So operational technology versus information technology. It's about a process, right? So I'm going to protect processes, not data. So I need to know everything and all the assets that are part of a process versus what are just the single devices. Goals of an asset management program, very similar to what you would have for all of your infrastructure within the IT side. You don't have to be a control systems engineer, electrical engineer, or someone skilled or has started out in OT. Could be a fine arts major. As long as you can follow this in IT mature programs, you can attach some of that. There's a 70 to 75% overlap for protecting those OT assets in those environments. And what we want to understand is the operational stack. Know what the processes are, and then know what processes are being executed, and then map those to the image that you see on the top, which is a information technology network diagram. But we want to be able to diagram what's going. What is the process that we're protecting? If you leave here today with anything, it's protect a process. We're not protecting an individual piece of IT equipment or a data asset. And then this becomes cyclical. So I figure out what my assets are, I figure out what the threats to those assets are, and then I'm going to start assessing what the likelihood is in terms of the attacks. Kind of speeding through these. I want to get to, give me a moment. Too many slides, Prakash. Apologize. So for risk, we want to take a look at the safety and assurance, operational continuity, regulatory requirements. We talked about this before. And then we want to figure out what our risk appetite is. So you can either choose to do nothing, which will land you in a court of law, or you can choose to take care of every risk that's there, which will deplete all of your funds of profitability. What you need to do is work with management, work with stakeholders and decision makers, and then figure out across all of this what's your risk capacity level and what's your risk tolerance. And then figure out to the best of your ability, analyze the who and the what, and this gets back to what are the threat actors that I'm up against, what are their drivers, what's their focus, and then I tune my cybersecurity program for the OT environment based on that. The only thing I probably can't figure out is when. And then that's your EDR, detection and response, being able to get clear indicators or early indicators of compromise. Internal threats can be disgruntled employees, proxy actors, hacktivists. And then we've talked about these common threats, improper network segmentation, third-party supply chain risks, insecure protocols, and then the common attack vectors, again, ransomware 90% of the time. And then this probably gets the most to what Brian was talking about and what I'll leave you here with today is walk through what the vulnerabilities are, what the likelihood is that the vulnerability could be executed, and what the impact is to get to the risk to the organization, to the process, to the community, but then also take a look at, across the bottom, a phishing email has a far greater likelihood than, let's say, at the end there, a zero-day exploit in a proprietary PLC. So when we talk about zero-day exploits, you'll find that a sophisticated threat actor, more often than not, is going to hold on to something that they found because they need to get the most bang for the buck when they're going to release that zero-day exploit. Because if they release it, then it's known. And there are threat actors that will sit on or that will hold, they'll hold on to that known information until they can have the greatest impact. But what you'll see in the years to come is a consistent, low-level, high-frequency, low-cost capability, and it's always going to be attacking the OT and industrial control systems from the IT side. It's too easy, it's low cost, and it generates far more benefit for the adversary. It's a business proposition. And you have to put yourselves into the feet or into the shoes of the threat adversaries. What can I do? What's repeatable? It's a lot like we talk about in terms of business or cybersecurity programs. What is something I can do? What's repeatable? And what can I get the most out of the dollars for? It's the same thing for threat actors. Proxy actors are going to operate a little differently. Your nation-state actors are going to be rare in frequency. I think that there's a few more. And then this is probably what I'll leave you with, is when you have asset management, we can start off with the problems that we had, know what you have, what are the risks, and be able to identify what the likelihoods are. Set your goal, and then create the solution. If I have an asset management program that takes all of these things into account, it becomes rather kinetic. And it's not just something for control systems engineers on the OT side. It's also for executive leadership. Here's what we need to do, and this is why. And it's also for the IT practitioners. So if you're on the IT side or you're in cybersecurity, again, you do not have to be a control system expert. There's plenty of articles out there about how different OT and IT are. There's a 70% overlap in terms of what we need to do. Why? Because everything's Ethernet connected. Everything's in a connected state. There's very little difference, and if you take care of these things, that's 80%. What's going to come at you from the left is probably the higher, more sophisticated, but there's a lower likelihood of that ever taking place.
So please come forward for questions.
Carl Arabit, Field High School. So I was just wondering, how do you deal with humans being the weakest link in cybersecurity? Like, are there like training programs to like teach like non-tech people like how to stay safe online?
There are, so within an organization, the blanket answer is going to be every cybersecurity framework requires that an organization have an awareness and training program, right? That basically takes you through, don't click on this, 12-character passwords, special characters, things of that nature. A lot of organizations have moved heavily into this. There's KnowBe4 and several other organizations that do for a software subscription, they provide this. Online, you could probably just do an open Google search. Actually, we don't even have to do that anymore. You could ask ChatGPT, what would I want to do if I wanted to protect against 80% of the threats that are out there against this laptop, if I have a MacBook or if I have this, if you're talking about for yourself, what would be things that I would need to do? In ChatGPT, I just saw a commercial. ChatGPT can create a workout program for you. It can also create your own at-home cyber resilience. You tell it what you have, and it'll come back and say, these are the things that you should be concerned with. But there is training that organizations have to go through. Do you guys do that here at the university? Yes, so cybersecurity awareness and training. The human is always going to be the weakest link, and trying to pull the human out of the equation is going to be difficult, even with automation, because it's still the human that develops the innovation and the advancement. You know, we're the dreamers of the dream, and so we're coming up with whatever's next. So it's hard to entirely remove the human from the equation.
All right, thank you.
Hi, my name is Lucy Nguyen, and I attend Dakota State. And my question is, you mentioned frameworks such as NIST, NIST 800-171 and CMMC. And I was wondering, when managing all the assortment of frameworks, how do you deal with scope creeping and governance fatigue?
So there is highway hypnosis. So if you want, you can still do it with spreadsheets, but what you have to do is a lot of crosswalking and cross-mapping. A lot of what we see today is there's compliance portals that make quicker work of this, where I can select NIST 882, CSF, ISA 62443, and as I'm answering questions within the portal and satisfying compliance adherence or compliance requirements, it'll start mapping it on its own. So when you solve for one, you're solving for the others. I think for myself, being a recovering IT practitioner, I spent about 25 years in enterprise technology and making all the blinking red lights turn green again. For me, which is normally against the grain, is the documentation. IT folks, the colloquialism is IT folks always hate documentation. I happen to like where everything fit. And I think for me, it's putting together the program and trying to assist, even if I was working for an organization, it's remaining focused on just where all the pieces should fit. But your question I think it's going to be one that everyone has to answer for themselves and within their own organization. But tools, automation, and software is going to be the key to expediting that. And what we're going to see in AI, so AI for OT, it's going to be in creating LLMs that can pull in mountains of information, much like a compliance portal platform. LLMs and AI are basically suited to that. You know, replacing somebody like me on the GRC and the governance side, it's taking a bunch of information about a network infrastructure, architecture, OT environment, and then scanning through the controls and then spitting out what the interpretation is. An LLM is specifically designed for that. In the next 5 to 7 years, there will be, no offense to Deloitte or KPMG or the rest of them, but your rank and file will probably slowly get replaced by AI, because all I'm doing is taking in information, analyzing, and regurgitating on the other end.
If If I may add, although AI use cases are going to be revolutionary, but we have to also have caution to make sure the humans in the loop is actually important, because you have to be aware that not what everything ChatGPT or AI says, needs to be re-looked at. So just a caution. Okay, got questions, please. Yes.
Hi, my name is Manuel Baku, and I'm from the University of Nebraska, Omaha. I was wondering, in a distributed control system, are there compensating PLCs in the off chance that one PLC goes down? What are like kind of the controls that are in place in case one part of the system kind of comes off?
That's a great question. So what we don't have, and you're starting to see it, is resilience in control systems. So when we wanted resilience in software and servers, we just created server farms, right? In PLCs, it's not quite that easy because the processes are usually pretty hard locked to the components, right? What you have, and what we talked about here in terms of the fire alarm system, is safety instrumented systems. And you can have a PLC that is also monitoring a system, okay? So if I've got a process that, let's say, is fluid flow, I've got a tank, I've got a pressure sensor, I've got a flow meter, but the secondary PLC or the SIS PLC is separate from the production PLC, different network, different VLAN, different communication pathways, right? But it's also got additional sensors that are monitoring. And in the event that something is, remember we were talking about a set point and then the process variables, if the SIS PLC is monitoring the process and the process is becoming degraded, it can assume that the master PLC or the process is offline and not working, and it will take over again to maintain safety of operation, or it'll fail safe, which is typically a shutdown. And it's not like in the movies where they go hit the red button. You're not always able to do that because there's things that are in motion. But what you have is it's not like redundant systems, but you have additional systems that are, again, monitoring the process and seeing what's going on physically.
Awesome, thank you.
Yep.
I'm looking at the time. We have 6 minutes, so if we can keep the questions short and response brief, then
Try
we
to keep
can
the
answer.
answers short, too.
Hey, my name is Ifyok Udoydiok. I'm a PhD student here at UND. I've been a software engineer for close to a decade, and I just got into automation engineering this year. And one of the major problems I have seen is I cannot find an equivalent of the Git system, the version control system in the automation world. I'm just wondering, I mean, aside from the Factory Talk Asset Center,
Yep.
I'm just wondering if there are other more generic ones and useful ones that are out there.
Yeah, so what Brian was talking about in terms of like the satellite manufacturers all kind of doing their own thing. On the control system side, while the protocols are open architecture and they're pretty well known, like Modbus TCP, Ethernet IP, BACnet, et cetera, the software to be able to talk to the PLCs is very proprietary. So in terms of application development, the closest in the manufacturing world right now, or even within critical infrastructure and software, is they're building application interfaces, and they're not all that secure anyway, because again, they're just exchanging open information with no authentication or encryption. But I don't think that you'd have like a Git repository for the development, so to speak. You have to live within, so when you had said Factory Talk, so that's an Allen Bradley, right? And so you have to live within their software. That's also why they charge extraordinary sums for licensing, because they can. But eventually, and we're starting to see this with OpenPLC, there's also Arduino. Young folks like yourselves who are challenging the status quo are pushing the industry away from that, and I think we'll be moving towards more of an open architecture. But there's still those challenges because all of those software companies are building code based on their own software or their own hardware and their physical manufacture.
Thank you.
Next question, this side, please.
Janessa from Dakota State University. What makes you say that nation states are less frequent in their attacks, less likely to occur? Or is it maybe that they're just going undetected and they're hiding well?
So you could have that they're undetected, but the reality is that if a nation state actor becomes detected, then if you think of it as a ladder, So, and there's a cyber persistence theory is a book deals specifically with this. So we talked about escalation dynamics. There's also a book called Cyber Persistence Theory. Escalation dynamics is essentially like a few chapters, but does a deep dive. And the school of thought is there's only so much that a nation state actor can do because there's always the risk of being found out. And then once that happens, it's an entirely different dynamic because now one nation can leverage all of its capabilities against another, and then you have cyber warfare. And I mean, to be honest, it's probably better that it's the lower frequency proxy actors because what we don't want is like two superpowers to, if there was ever a recipe for disaster for humans in general, it would be open warfare and it's not even that. What we do experience is a low grade, but nation states are they're very specific about what they're going to engage in and what they can keep unknown. But that's the reason, is that if they get caught doing something, hands in the cookie jar, the escalation dynamic that now exists becomes very direct between two nation states. It's far more profitable and efficient to have proxy actors doing that for them, and especially in the lower sophistication, higher frequency that we're seeing today. Not to say that's not taking place, certainly, and the remaining undetected, but once that detection happens, it's an entirely different ballgame.
Thank you. I think we have two more questions. So why don't we ask both the questions same times, then he can respond to the questions. Can you?
So Malachi Reynolds from Dakota State. So I'm sure you're familiar with the Purdue model, the network security architecture. Are there any other models that are kind of breaking out or any modifications or evolutions of the Purdue model that are being used?
Yep. So one, the Purdue model is a model in 90s that was based on time. And cybersecurity people, because the OSI layers gravitated to that and said, oh, it's got levels, so we'll just do this, this, and this. And so it's important to understand that the Purdue Enterprise Reference Architecture is not a security model per se. What it is the importance of time within an OT environment in a system. Now, but you take a look at within ISA 62443 and the ISA Working Group 99 came up with, in their write-ups, it's all about zones and conduits. So I have a zone that protects the process. I have a conduit that is going to be communication with that process or other processes outside of that. There's also the MITRE ATT&CK framework, which is very well done for ICS. That would probably be ISA 62443 or the MITRE ATT&CK ICS. Those would be what I'd be looking at. But what we want to do is be very clear about, para is good in terms of, an illustration, but it's not to be used as a framework specifically.
The last question.
Hi, I'm Amit from University of Wyoming. So my question is so I believe from your talk, we need to design a system in a way that even if there are security breaches, it needs to be functional. So how do you ensure that the system transitions from the from the degraded mode to fully functional mode? Do you follow backward recovery or forward recovery mechanisms?
So if I had a control system that went into a degraded mode, right? And then how would I come back from that? Yeah, so that's going to be, it's typically I don't want to say a manual process, but there has to be a human intervention. So if I had a water treatment plant, if I had a fueling system at a railroad yard, if I had a failure of a pump, and I could no longer use that pump, but I had other additional pumps, lines, and piping to like a fuel tank or to a water tank, it's going to require that's where it's the physical, not the cyber, but the physical. So there'll be some sort of a physical maintenance period for whatever piece of machinery or mechanical component has failed, and then you would have the primary PLC system or automation would simply take over. Now I'm short hopping it in terms of what simply takes over means, but the SIS system or the secondary PLC, it's there to monitor the safety of the operation and the productivity operation and then shift over. And then once the repairs have been made, then you just shift back.
Thank you.
Okay, thank you. Let's thank Paul for his time.
Thanks. All right. Thank you.
So we are on time. Now we have nice snacks for you. And for next half an hour, and 11:15, we're going to come back here with our next speaker.